Rubber Duck Engineering. We're going to go tracing again.
This time we're actually going to do it this time. I have a good feeling about it.
I also have a feeling. And for those of you watching us live, sorry we're late. Things happen. Anyways, how are you, Dr. Barth?
I am great. You're supposed to ask me about pizza because we actually had pizza tonight.
You had pizza?
Yes, and I followed the advice in the pizza recipe book that I have, which is to add the leafy ingredients after you've taken the pizza out of the oven, after you cut the pizza, just put them on top as if that was the thing to do. And it turns out it tastes amazing because what happens is the heat of the pizza wilts the arugula just a little bit, and it's delicious.
We have not yet made pizza, but we continue to make bread. That's
I'm sure you can put arugula on top of the bread too. It'll be delicious.
So as we were saying, tonight we're going to go tracing. Oh my goodness, look at this.
Hi, Leo.
Nice to see you. Thanks for coming. We're going to do some tracing. You did a bit of work behind the scenes. I saw some patches come in.
Yes, I did some of the things that we talked about in the last episode. Oh my gosh, everyone's here. It's a party. Welcome. Yes, so what I did, a couple things. So remember near the end of the last episode, we were trying to add types to the pointers to distinguish between the object pointers and the header pointers. So I did that. I got that working. This is actually one of the things I really like about Rust is it's pretty cheap to just add all these extra types to things, and then you can not mess up your adding and subtracting for from everything.
Should I pull up the code?
Yeah, pull up the code.
Okay, let me turn on the code machine here.
And the other thing I did is I added the unit test that we talked about, which basically checks that the number values are preserved during garbage collection, which seems like an important property of a garbage collected system.
Let's see. So I'm just trying to pull it up so the folks can see. So you made this object header be able to have this header pointer and object pointer.
Mm-hmm. And so if you go click on one of those types, you can see they have methods on them to convert back and forth. So it's like to header pointer gives you header pointer, and then to object pointer gives you object pointer. And that way, the type system makes sure you don't add twice or subtract twice.
Makes sense. I think I remember looking at this right after you did it, and this is still more unsafe than it needs to be.
Yeah, I think that's a place that we can improve.
Because if this was our own method that only took header pointers, for example, then we could enforce that we did it right. We wouldn't make it possible for this new pointer to accidentally be a object pointer or something.
Oh, and we had that bug, by the way.
Oh, we did.
Yeah,
that's right.
I wish I had caught it with the test, but I actually caught it while I was thinking about the test, which is a common thing that happens. That we were using the object pointer instead of the header pointer, so we weren't copying things correctly.
And then you said you added some tests down here?
Yeah, I added the I think it's the last test, or maybe it's the first test. Number value test, this one. Yeah, that one.
Number value test, where you create two numbers, you set their values, you don't do the math because whatever, and then you verify that they're still there after a collection. And then they're Rust stuff.
Yeah, that's probably a way of actually asserting that they moved during the collection, but.
Oh, interesting. They're pointers or something.
Yeah.
Okay.
Hi, Revel. Welcome.
It really is a party tonight. My goodness. Okay. So going back to our list from last week.
Yeah, should we check out the things that we've actually done?
So let's see. Make it possible. We did this.
Did that.
And make a second object type.
We did that. Right? We have the host. That. Oh, we did. We have the host object type.
Oh, that's right. Host object. This is why we had to. Did we actually do anything with the host object?
No, but that's not what the list said. We're just doing what the list said.
Okay. So we made a second object type. Make a host object with a finalizer. Okay.
So remember, that's where we left off. We have this test that fails, which basically shows that we don't, after garbage collection, we don't actually drop the host object.
That's right. Cargo test.
So I think the next step we should do is to make that test pass.
Okay. And if we look at our finalizer test, which is going to be here, Man, IDEs have just gotten so good.
Yeah, the ability to just like jump around from things is fabulous.
I just remember this stuff being so hard. Like I remember my first experience with UI programming beyond HyperCard was like typing in the 3 pages of code to put up a freaking window in OS 9 out of a Mac Tech magazine.
And was there a
like,
typo in there somewhere?
What'd you say?
Was there like a typo in there somewhere that caused the whole thing to crash and burn for an hour while you figured it out?
It was crazy with like some third party, like this was way pre Xcode, or Xcode was part of Next or whatever, and not part of Apple then, but like, yeah, anyways, just the world has gotten so much better. Okay, so this is not our test. Took me the wrong line. This is our test.
Mm-hmm.
And we're expecting.
Right, so we the drop trait for this object goes and increments this counter. And then we expect that after we collect that the object actually gets finalized, but what actually happens is we leak the memory.
Okay, and so here, we're not actually doing tracing yet. We don't need to, but we do need to do this part.
Right.
And we don't have the vec of weak pointers yet.
Correct. So I think we should make the vec of weak pointers.
Okay, and that's just going to go on the heap.
Yes.
Okay. So these are like finalizers, or what are we putting here?
I think we should go in heap inner actually, because we're going to want to mutate it.
Okay. Oh, in fact, it's right there. Are these just weak pointers, or is this just for finalizers?
They will eventually be weak pointers, but I think we can start out just with finalizers for simplicity.
Okay. And so that's like a vec of closures, function calls. What do we got here?
That's a good question.
A vec of pointers, any's.
So we're going to need an object pointer. We're going to need a new structure, okay, which is going to be like, let's call it weak cell.
Okay.
So we're going to need
T?
What?
Like weak cell T?
Well, this is probably the wrong name. We'll think of a better name, but we somehow need the object pointer and then some sort of callback or trait. So basically, when this object gets collected, why don't we not do this part yet? And when we get to this part, we'll figure out what to put here.
What? Yeah, like what is it we're trying? In the end, we're trying to call standard mem drop on the right T.
Yes. So we want to basically, after we collect, we're going to scan the scan this list to find the things that were collected, and then we need to call through something that causes us to do something specific to the box, to the host object, to put the pointer back in the box, so that Rust can then drop it.
Oh, I see. So this is like not our global list of all finalizers. This is like the set of finalizers we saw in this collection, or the set of objects, host objects we saw in this collection.
This will be all of the objects in the heap that have finalizers.
Mm-hmm.
And so then when we do the collection, we'll scan this list and we'll call the ones that actually have finalizers. We'll call them back somehow.
Okay.
So I was thinking maybe we should rename cells here to roots. These are really the roots.
Yeah.
The globals.
Maybe we should do that before we do any of this. Like that's trivial, right? Is this?
So you just want to skip the cell. Let's have a cell because we're gonna need a second member here. I think we just do this to start with.
Okay, great.
So then, down here when we say take object online,
follow you. Yeah. There we go. My new following technology. Okay.
So somehow we want to say self inner.
Borrow mutt.
Objects with finalizers dot. Right, I push.
Push, yeah. Yep.
Global handle. How do I get the? I want the object pointer out of this. Wait, we got too clever here.
We got too clever how?
I lost the object pointer.
In our take object?
Yeah, because this is a this handle is a global handle. So we'll just call get pointer.
Well, okay. The global handle is what we're passing in. Oh, I see. There were. Okay.
We need to add that function to
Handle.
To handle. Just fine.
Okay. This itself is kind of unsafe because, like, what's the lifetime of that pointer? What'd you say?
Okay. You have different underlines on your screen than I have on my screen.
We have weak cell does not implement debug. Which is fine.
Okay, that's fine.
This is a massive syntax error. Expected semicolon. Yeah, fine. Semicolon. Field PPR. In option. Oh, it's just unwrap it or something. Cannot move out of index.
If
Made as ref.
We could just as ref.
Oh.
Okay.
Yeah. That gives you an option with the ref inside instead. So it doesn't steal it out. Okay.
So we added this thing, which is good.
Well, the function that we just wrote, this get object pointer, is like very unsafe.
Well, I think my understanding of Rust is that the pointers themselves are perfectly safe. What they decide is unsafe is like operations involving the pointer, like dereferencing the pointer.
Okay. It's just like there's no associated lifetime with that object pointer.
That's true. I mean, maybe we're factoring this wrong, and we've created the global handle too early, and we should add this logic like deeper in the allocate function, because the allocate function is dealing with these like it has the pointer.
I think that would make sense.
Let's add it to do about that. Like I think I agree with you. Like maybe we should remove this function. It's unsafe.
Well, it also just makes sense that do we call take object every time it's moved between spaces, or is that only when we pass it into our system, pass it into our heap?
This is when you pass it into the heap. Maybe we can have a better name for that. But this is like
it's like alloc host object basically.
Yeah. And this I agree that this work here. Allocate where we have access to the pointer.
Yeah. And that just makes more sense because it's just extra work as part of the allocate. Like whenever you're allocating, host objects are special. Well, I guess you were saying that everything is a host object, and there's like a specialization to not have that. But they're different from your normal heap objects in that you need to also retain this ability to finalize them. What you up to?
Yeah, so now we're in collect. So what we need to do is we've copied over the object to the new location. And now we want to leave a marker behind to explain what we've done.
Why? Why is
so,
an extra write necessary?
So when we do tracing, we're going to have to do things like color the header to say, oh, we've traced this object before.
Yeah.
But then let's write the scan and we'll see why this is.
Okay.
So let's scan for so in here, objects with finalizers. We basically want to say you basically want to say something like this. You want to say if the object has moved. We figure out exactly how to do that. We want to update. Let's write this in pseudocode first. If the object has moved, update the PTR in the cell. New location.
Okay.
Otherwise, call the finalizer. Then while we're doing all this, we want to build the object with finalizer list for after the collection. Does that make sense?
If the object is moved, update the pointer in the cell to the new location. Otherwise, call the finalizer or put things in a finalization queue. It's probably where that actually goes. Maybe this is the.
That's fine. We can. That's better to put them in a finalization queue.
While we're doing all this, build the object with finalizers list for after the collection. Oh, I see. Basically, do the remove or something.
Yeah, this is gonna be like new finalizers. This is one of these. I don't know which of the fun.
So this is sort of like a where. This could be represented as a where. Oh, it's a little weird to do this in a callback. Like a where operation on a list. I'm not suggesting we do that there, but it's like a where.
You both want to filter the list and mutate the entries as they go by. I'm not sure what the Rust idiom for that is.
Yeah,
but the simplest thing is we can just build a new I'm not up on my.
Oh, you know what you're doing actually is you're splitting the list, or you're filtering into two lists, right?
Yeah, you're filtering into two lists and modifying one as you go.
Well, but the modify one is the modify pass is separate, is it not? I guess you don't want to lose the information that you're collecting while you're iterating through, right?
Yeah, it's so I think we do like we're gonna make the header super vague for now, but
super vague, you said?
Well, there's gonna be a bunch of information that we put in the header, like where's the header? Object pointer, like so. That's heaps out. Where's object header?
Object pointer, right? Or you're talking about object header? This thing. Object header is on line 267. We put it at the end of the file for whatever reason.
Yeah. So we have the size here. So I'm just going to add a bunch of junk here that like eventually we'll use like a union or something to
Sure.
save space. But for now,
Yeah.
we're just going to make it really bloaty.
Yep,
So we're going
that's
to put
fine.
like new pointer, new header is like option header pointer. So like
New header.
when we move the object to the new space, we'll record here in this field location. We'll record this field where we moved it to.
I remember Ren's GC talking about graying objects. Is that what this is? Where you're like marking them that they... I guess Ren's GC doesn't compact, so it doesn't move objects.
Yeah, so like we'll have to keep a bunch of state information in the object header related to where we are in the collection. And so we can write out what all the fields are. There's we'll add them as we go, but they're all going to compress down to fit in 64 bits, or actually we'll eventually get them to compress down to 32
So
bits.
we'll union them, yeah.
Yep. But for now, let's just explode them all out.
Yep, makes total sense. But this is the... When we move an object, we need to leave a pointer to where we've moved it so that other things can know to update their own pointers, because pointers within the heap don't jump through handles. They're
Exactly.
direct.
Correct.
Okay.
Right. So when we later encounter an object that points to this object, we have to know where to update that pointer to.
So when we move pointers within the heap, and this is why we have to do all this tracing, is because we have to update all these pointers too.
Yep.
Yeah, we have to be able to trace the entire object graph. Okay, this all makes sense.
Yeah, that's another way of seeing why you need this data structure. And you could build like a side lookup hash table or whatever, but since you have it all there anyway. Okay, so we've copied all this stuff over. So now what we want to do
Working on this, our pseudocode.
Oh, well, I was actually going to now populate that field.
Oh, okay.
So the what do we call it? New header equals new pointer.
Yeah, so this should probably be, this header should probably be like old header.
Yeah, that's old header.
Old header. And this new pointer is new header.
Right. This is new header.
I see, but one's a pointer and one's not.
Right. So this will be new header pointer.
Okay. That makes more sense. And so now this is old header, new header pointer. Oh, I renamed this one by accident. Right. This is...
That's fine.
New header. Okay.
This is a pointer.
Right. So we just have to go... Whoa, sorry. So we have to fix our... All right. This is good. New header pointer to object pointer. Yep.
All right. So we can actually just... We don't... right. Yep.
This all makes sense.
Here... So now we can do this. We can say...
Oh, we need to make this sum. That's fine. Fixing, go ahead. Oh. Okay. Okay. Please continue.
So we have cell dot pointer dot to header pointer. And I'm not sure how we reconstruct the header from the pointer. We did that here. Object header. Object header. Oh, we can just use this.
I'm sorry, that gives you a mutt borrow?
Yeah.
What did you do?
Okay, so this is our...
I'm just not sure this is safe. That's what I'm... I
don't know what things are safe or not.
I mean, I have some experience with this from dealing with the C. The self from header pointer. What is this doing? Unsafe. As mutt. Okay,
this is giving you an object header reference from your pointer.
Yeah, the question, what happens to this reference? Like when this reference goes out of scope, what? I guess this is just a borrow on it. It's not going to kill the actual underlying object. Okay. I think this is okay. They
So
warn
how
you, by the way. They warn you, by the way, to never do casting, like never ever do casting across mutability. I don't know why, but they talk about it as being like even more unsafe than unsafe.
Yeah, I suspect that we will have to do a pass on this thing to clean up the safety and unsafety once we get
Yes.
like we're playing a little fast and loose with like, oh, unsafe, no problem.
You're
So if the object is moved, which is fine, then we want to say cell.pointer equals old header to get how to get the object pointer out of the header pointer to object pointer.
From one header, your header pointer is some. Objects with finalizers. Oh, I see. Okay.
And
Does
then
make sense.
We want to do the more equivalent of this.
Mm-hmm.
Otherwise, we want to move to the finalization queue.
Mm-hmm.
So this is like objects in need of finalization.
We'll just call it finalization queue. Okay. Those are cells, yeah. Okay. All right, this all makes sense. This is going to end up as a helper function, but
yes. And then before we clear the now we need to drain the finalization queue.
mm-hmm.
So we don't know how to like now is that we need our back reference. Like we need the other field in the cell.
So I pushed for the finalization queue, but I may actually not understand why we care. I cared about it in the ref counted world because I was trying to prevent sort of, Stack Overflow.
We don't have to do it here. Like it's a little bit. We're in a sort of vulnerable state to make all these upcalls. But
I just worry that I've pushed us to premature optimization, aka the root of all evil.
just really consider deferring to finalization queue so that we're
I see.
in a less vulnerable.
Yeah, okay, that does make sense. Yes, because you might want to call out, right, of your code that you control into arbitrary code at a more defensive posture in your code.
Because we're like in the middle of iterating in the middle of our collector.
Yeah.
Like, that's okay.
Yep,
like,
makes total
we'll get there.
sense.
So now we need to figure out how to finalize. I'm running it your way, Eric.
What are you running my way? Oh, with pseudo, with the
Probably
the imaginary
that
code
exists.
Have I actually converted you, or are you just
No, I'm
teasing me?
trying it out. So now we decide how we're going to do the upcall. I think should we start with the trait?
William says, I appreciate you grappling with this. One thing I've wondered is how do you implement heaps to support interpreters that don't have Rust heaps invariants? And here you go ahead and do it. That's kind of how we approach life, is we just bang our faces at things until either we win or our face.
I find this is a good way to learn. Is just to try. Like I have sort of a vague idea of how these things fit together. Like I don't really know it, but like you can work through it in a principled way, and you can sort of get there. Like sometimes if you don't have the sort of background knowledge of it, you can find a book, and then rather than copying out of the book, you sort of get the ideas from the book, and then you sort of put the book away. Then you try to do it, and then you get stuck. And you're like, oh, how did this work? Then you pull out the chapter. I don't know, I've done that a bunch of times in my career.
I find in exactly that manner when I go back to the book the second time or the third time, like it makes so much more sense now that I like have some miles on my boots.
Yeah, because often as the person who wrote the book's like an expert, right? And so they'll say the important things, but they won't really quite realize like what are the things that as a newcomer are not obvious to you, or maybe they're different things are obvious to different people.
Yeah. So here we go, putting some miles on our boots. You were.
I would say let's try to do with a trait. Analyzable.
Oh, I see.
Analyze.
I mean, isn't this just standard mem drop? Isn't that what finalize means in Rust?
We drop is. Oh, you want like a dyn?
Well, what calls the drop trait in Rust?
The drop trait is called. I don't know if you can. You could just call it.
I mean, like the drop trait in Rust is the finalizer for Rust, is it not? And I assume that standard mem drop does that. But I don't
know. Yeah. Okay.
Like
so.
How to call drop in Rust. Rust doesn't let you call the drop trait drop method manually. Instead, you have to call the standard mem drop function provided in the standard library.
But we're in like weird. That's normally true.
See,
the standard mem drop is really nothing. They show you the implementation, and they're like, this function is not magic. All it does is receive a value by move, and then.
Well, the way we do this is box from raw. We just slap it back in a box, and that'll finalize it. Right? Like, how did we get it out of the? In the same way that we.
But the other thing we can do is I think we can just call. Like, how do we do this with the global handle get mud, like this thing, like this bit of magic here. So
which bit? I'm sorry.
I just copied. Okay. So let's try to fix it. So this is going to be self adder as. So we don't know what the T is. I think that's going to be the problem. We need something to remember, like which drop we're going to call.
Well, that's what the host object's job, isn't it? Host object's job is to remember the T. And so maybe host object needs a drop trait?
Well, that's why you want some kind of dynamic thing here. Like you want to write like dyn drop. What if you had that? And you could just say
no, what I'm saying is that you literally call, there's this function box dot from raw, and if you shove a pointer in that, assuming you know what T it is, when that box goes out of scope, it does the drop for you.
Okay. Yep.
So if we had the T somewhere, we just do box from raw, and our thing gets slurped back up into Rust land and let go of appropriately.
Yeah, I'm with you. So I think we need something to remember our T.
And again, that's where I got to, isn't that like literally host object's job?
Yes. But we need somewhere we need a dyn. Like we need to call a virtual function somewhere to unerase, like we've erased the type. So we need to get the type back by calling a virtual function. So I think this will work. I think we say trait finalizable, and then we say fn finalize okay. We keep around a dyn finalizer, and then we say self.finalizer.finalize self.ptr.
Mm-hmm.
Now all we need to do is have host object implement this trait. Right? And we need to populate this field. Let's see if we can implement finalizable for host object.
Don't fully grok where you're going yet, but that's okay. I want
Let's finalizable for host object T. Right? And then I forgot. I could be have all this thing all backwards and such.
okay. We were just telling William, we gotta try it.
What was it? It was box T, and now we have the T again, right? Recover the T.
Yeah.
Then what do I need to pass in here?
Just the pointer that we're giving back to Rust. That we stole from it before.
We do like convert its type, right?
Yeah.
Star mut T.
Mm-hmm.
Okay.
Yep. And then, like, ideally, we want this object pointer to die too, because that pointer is no longer ours once we do this from raw. Rust now owns the pointer again.
That's the caller's job. Like it finalized this pointer. It can't do anything with it afterwards.
I see.
So the last thing we need to do is we need to record. When we created our weak cell here, we need to fill in the finalizer, which is just going to be like this. Does that make sense? How do I get the
I'm so confused. Like,
oh, what if this was a host object finalizer T?
Like, why does the weak cell, like, why doesn't the weak cell want to just hold the box?
Why doesn't the weak cell want to just hold the box? Okay.
I don't know. Like, we could just use Rust lifetimes to. I mean, this into raw rips the pointer out of the box and it's like, it's no longer yours to hold on to, but maybe we don't need to do that.
Mm-hmm.
Maybe there's just a like box, show me your pointer. Like, why do we want the show me your pointer? We don't actually need it. If we have a way, well, I see the weak cell isn't the thing in the heap doesn't have the.
Yeah, I mean, that maybe is a good idea.
We're going to parallelize this with choice here.
Should we try it that way?
Yeah, I don't have strong enough opinions yet to really push us. If you felt like you were inches away with host object finalizer, let's just finish that journey and we can refactor.
I think this is inches away. Why don't we go a couple more inches, and if it doesn't work out, we can
Great.
try. I think the approach that you described will work too. This is just another one of these phantom things.
So basically, then these just become like boxes. It's not finalizers, it's just boxes. It's the things we're holding on to, or host objects.
Yeah. I think that was it. That what is? We have 5 errors, so we'll see.
Trait finalizable cannot be made into an object.
Huh?
Isn't that exactly what you do with traits? Dying trait. For a trait to be object safe, it needs to be allowed building a V table.
Okay.
Turning finalize into a method by giving it a self argument.
Okay, that seems fine. We can give it a self argument. Go for it. Give it a self arc.
Do we want it to consume the thing itself that it's finalizing?
No, just give it ampersand self. I think it's fine.
Neat feature of Rust, by the way, that you can have a consuming self. Does not implement debug. Okay. Is there a way to imply that finalizable has to imply debug?
Just say plus debug.
Oh, as part of this thing.
Yeah.
Okay. Expected trait.
Oh.
There's a way to. I've had to do that before. I don't remember. No field to object pointer on option.
We can just get rid of debug for weak cell. Like we keep inner. Why don't we just manually implement debug for heap inner?
Weak cell doesn't implement debug.
Let's just must.
Why do we need these debugs for anything?
We need them for the unit tests for some assertions. So we can just do this.
To object pointer is not an option. We need to unwrap here. Oh, I need to stop following you.
I'm just making this debug thing work.
That's fine. All right. Figure out the resolve format. This is standard format. To object pointer. This is going to be unwrap.
Oh, we can say let some.
Oh yeah, we did the let some trick. Yeah. This is new. Q. And this is, yep, you got it. Yep. Attempt to take value. Okay, yep. Comparison operators cannot be chained. Does this need the fish?
Yeah, more colons.
Colons. No function associated with new.
Just say default. We'll add the default trait to it.
Okay. Yeah, fine, we'll do that. You're on it. Default. All right, functions associated with default not found for this. Doesn't satisfy default. Consider restricting type parameters to satisfy default. Where t:\default.
Okay, fine. We'll just make a new. It'll be okay. I'm sure there's a better way of doing this. I just don't know.
Well, we're doing the last inches before we rip this all out and do it a different way anyways.
I don't know how to make it.
We talked about this on the last show, just like the importance of getting all the way there.
Yeah, like, but the tests are what you're getting to, like that. Then that allows you to then do the refactoring.
To work backwards. Cannot find T in this scope. Did we miss? Is this supposed to have new T or
more T's?
More T's.
More T's.
Missing generics. More T's here.
Self.
Oh,
Self.
Sorry. Oh, hold on. You type.
I learned the power of self.
Ah, yes, the power of self. Big self.
Big self.
No function associated with default. Yeah, that's because now it's called new. Okay, mismatch types. Expected struct, Bach, dyn, finalizable, and
You gotta
static.
show that in a box.
What? We need more boxes? What?
More boxes. Rust won't let you hold like a raw dyn or whatever.
Parameter type T may not live long enough.
What? The type parameter has a lifetime?
What?
You're killing me here.
No function or associated item named new found in struct phantom data.
How do you make the phantom data?
Trying default. Method finalizes a self-declaration trait, but not in the impl. All right.
Okay.
He's
More
got
colons.
More colons. What? Attempted to take adder value of method. Oh, this is adder. I mean, wouldn't it just have gone out of scope the next line? Like, I don't think you need to manually drop it.
I think it'll complain if you don't.
Oh, okay. Parameter type T may not live long enough. This operation is unsafe. What?
I
So-
agree, it's unsafe. Okay, so we're down to this.
The parameter type T may not live long, so that the type meets required lifetime bounds. How does a parameter type? How does it?
Are your types gonna have lifetimes?
How is that even possible? What does that mean?
I don't
Aren't
know.
types static?
Maybe not. I don't know. This is a totally mysterious. Like, why?
Did we like give the type a lifetime? You just saw another trick, by the way, is to like solve all the rest of the errors and then come back to the hard one.
Because sometimes it's generated by some other thing. Like, you just had to add more colons somewhere, and then it would solve it.
At least this happened in C++ all the time, that it wasn't always the first error that was wrong. Okay.
Can you click on this Rust E whatever? Sometimes these articles actually tell you something useful.
The parameter type is missing lifetime constraint.
Type parameters have associated lifetimes.
Today I learned. Okay, well, let's T:static this sucker.
Okay.
Do we have to do it every single place that T is mentioned, or just
No, I think we should just do it right in this this function here, the allocate host object. Like, it's right there.
Oops. Okay, cannot move out of reference.
Oh, that's totally true.
Yeah. Okay. Mm-hmm. Cannot assign cell. You just made it mut. Mismatch type. Expected struct found mutable reference.
Oh, maybe do it like this.
Sure. Yeah, that would work. Should work. Okay.
Does the test pass? I mean, that was the goal. No. Oh wait, a different one fails. Oh no.
Already mutably borrowed. Borrow error.
Oh, okay.
So we're borrowing in get object pointer, which we already decided was unsafe.
Okay, we need to fix this get object pointer problem. Like this we decided was wrong.
Well, let's see what it is that we're.
It's sad because the inner is already borrowed. Like it's exactly the problem that you were talking about. It's just the Rust has hopefully found it for us at runtime.
Okay,
the Rust runtime is like, your design is wrong. Please, all those to dos you write, we want you to cache them in and please make them true.
Back to the whiteboard with you. Okay, so this I see. We want to shove this inside the allocate. Do we need like a different allocate for?
I think allocate we just want to have like a what if we made this return like the global handle and the object pointer.
Why? Don't you?
No?
Like
What
the
do you want
weird. So.
Oh, you want to say allocate with finalizer?
Yeah, I think so. Like you want to, like isn't there a difference between allocating pure heap objects and host objects?
Yeah. Allocate with finalizer.
Mm-hmm.
So then we just need to do this thing.
But then I worry that this thing you could end up calling the wrong allocate. Like, should this be a match on the T or something like that? Like, what if this allocate just matched on the T or something?
Can you do like a negative trait? Be like T that doesn't implement finalizable?
Yeah, I don't know. Or can you do a specialization? Like you used to be able to do this in C++, where it's like, well, when you call this thing and it's this specific type.
Yeah. I don't know. These are good questions.
Yeah, I don't know what the rusty pattern is here. But it just feels weird that this is a foot gun, that if you accidentally call this with a T.
All right, so okay, what if instead of returning a global handle, this thing returned an object pointer, right? And then we had like this part of it goes somewhere else, right? Is you see what I'm getting at here? It returns the object pointer.
Well, so isn't there another way in which we do just like match T? I don't know if you can do this. Object. It feels weird that I'm matching on types here, but like that doesn't make any sense, does it?
I don't think you can do that. I think the match is a syntactic thing. Full handle T. Okay.
We're not actually going to get to tracing today.
I lost the well, we'll just keep trying.
We're going to keep having the tracing episode until we trace. Our apologies to all of you playing along with us.
Right, so like let's call this one can be pub. Object. Then allocate host object calls allocate object pointer. This.
What? Is that the only place we call allocate? I'm not able to find this.
Is it any more errors? What are the errors?
Try expression alternatives have incompatible type. Expected struct object pointer found struct global handle T.
Oh, that should be allocate object.
Type annotation is needed. For global handle T, type must be known at this point. This is just allocate handle needs to have a T?
Oh yeah, I think that's right. More goals.
No field value pointer. Oh, I see. What this is number? Oh, what's going on? Oh, I see. This is not T. This is
oh, host object T.
Can't borrow self-mutable is also converted to mutable.
Oh, you can just split it up. This is the weirdest thing in Rust. Like, I don't understand why. Let's have to do like the order of evaluations or something. Evaluates the function first or something.
Can I borrow handle is mutable? It's not declared as mutable.
Insert more mutts. What?
So variable does not need to be mutable. But before we leave this, why is this? Like, should this allocate host object thing just get pushed down into wherever we're calling this? Alloc handle. This is the thing that we're trying to move inside of the inner. Are we not in inner here? We're in heap. Like, isn't our major... Okay, anyways, we can just fix this. I may be too tired to solve this in my head here. Variable's not even mutable.
Yeah, I think this is not quite factored correctly. After the show, we'll refactor it to be a little cleaner.
Ergo test. What do we do?
Okay.
And we have mutable borrowed again. Press status heap corruption. That's new.
Oh boy.
I love it. I love it.
Wow. I have not gotten Rust to corrupt the heap before. We did it, team.
Yeah, that may be where we end tonight. If we manage to corrupt our Rust heap. I think we need to take a step back and do a little bit of sanity refactoring with fresh eyes, maybe on a Saturday morning and not like at 9 o'clock on a Thursday.
I think we can also try your approach of keeping the box around. Like, we're going through all this work to rip the box apart and then put it back. Whereas it may not be necessary. We can just keep the box around in this vector.
Because the box is like, this is mine. Just keep it on the heap, please.
Yeah.
And that's really what we want. And we just want to control when we let it go.
Mm-hmm.
Why do we ever even need the pointer inside the box? We could also just keep the boxes in a vector and hand out indices. Maybe that's not quite right.
Yeah, we could totally do that. Like, if the thing we have in the heap is just the object pointer, the object header, and the index into the
into our boxes that we're holding on to.
Yeah, I think that may be a better design for Rust. Like, this is the sort of the way you do it in C, but I think what you're describing makes a lot of sense from like a Rust type safety point of view. Like, it would reduce the number of unsafes in this code by a dramatic amount.
And we also then could do like, we could compact our, our box storage if we ever needed to too, by we just like in one of our walks, we just update their indices or whatever we need to do.
Mm-hmm.
Or we could grab it. Yeah, anyways, I could imagine a bunch of Rusty sort of ways to do that. Rust really wants you to use indices into vectors instead of pointers.
Which is what we ended up with for the global handle. Like, when you do this in C, the global handle doesn't end up with an index into a thing. It ends up with a pointer.
William says, you'll need to do something similar for GC roots. I'm not sure I follow.
I think that's basically true. We did do something similar for GC roots. Like, if you look at global handle on line 255, ultimately what we have is an index into the roots table.
Yep.
And I think
this is what I found in the Wren code is that Rust, so the Wren C code is all pointers everywhere. And Rust just really wanted me to have indices into vectors.
Mm-hmm. Okay, I mean, this is like in the category of learn by doing. Like, I'm glad that we tried it this far. Like, this is the first time I've ever gotten the Rust compiler to eat some code and have it tell me heap corruption. So I think that's a strong indication that we're on the wrong track and that we should rethink some of this.
I really feel like we should get a badge somewhere for this because
I corrupted the Rust heap.
I corrupted the Rust heap. Yes, I need the T-shirt.
I mean, to be fair, we're using so many unsafes that like it's much harder to do that without unsafe.
We're only using 12. That's probably 11 more than I used in the entire Wren project.
Do you want to make that as a comment so then when we complete the refactor, we can see how many unsafes we have? Because I think it'll be a lot less.
Okay, so I'm going to commit this as work from RDE number 70. This is achievement unlocked. We corrupted Rust Heap. 12 unsafes currently.
Yes, exactly, William.
This is achievement unlocked. Yes, I totally want the t-shirt. Okay. Well, that was a lovely
It was a learning experience.
Yes, it was a learning episode. I mean, I learned something every time we do this, but
yeah, we'll try again next week. We'll eventually get to tracing. Like it's gonna happen. It's just a matter of time.
Anyways, it was great to see you, Dr. Barth. Wonderful to see you all tonight. And congrats on the pizza.
Yeah, thanks everyone who showed up live, and we also appreciate people watching on YouTube too as well.
Yeah, it's super awesome to have all this commentary. Point us in the right direction. Anyways, we'll see you all next week for another episode of Tracing.
See you.